We have all of our same properties with multiplication of rational numbers that we had before: commutative, associative, identity. But we are going to add one. We have not looked at the inverse property of multiplication. We did look at the inverse property of addition. So let me just remind you of what that one is. So if we -3 plus 3, for instance, gives me 0, or 5 plus -5 gives me 0. So in its formal term, a variable plus the inverse, which is that negative number, we had that with the integers back in chapter 5. We have not talked about the multiplicative inverse because I needed rational numbers before I could do that. So that one was not gone. We didn't go over it with the addition. So this is the multiplicative inverse. The multiplicative inverse, so if I have a number, a over b, if I flip that, I don't want to have an equal sign there, I'm going to multiply. If I flip the numerator and denominator, that's the inverse. That equals 1. Let me give you some examples. So for instance, 3/4 times 4/3 equals 1. We could do it with whole numbers as well. So 7 times 1/7 equals 1. It's a little bit harder to see that, but remember a whole number can be written with a 1 in its denominator. We kind of invisible because we don't need that most of the time. It's extra information. 7 reduced down is 7. It's not 7 over 1, but we could think about that if it helps us see that inverse a little bit. Inverses are very useful when we're solving algebra equations. So here we've got that 3/13 out front of the p. So if I need to get that variable by itself, I'm going to multiply by the inverse. So that's 13/3. So these fractions are going to cancel out, and I'm going to be left with, I'm going to multiply this out. Let's see, -6 times 13 is -78, and 5 times 3 is 15. And of course, I want to reduce those down, so my final answer is going to be -26/5. While we're talking about multiplicative inverses, we want to go back to that mixed number. I know we saw it already in this section when we were multiplying the mixed numbers. We have to write them as an improper fraction. It's going to be the same deal here. So those mixed numbers, they're actually really easy to think about, like actually the quantity, but when we start doing calculations and computations, they're not as super helpful. So we're going to have the constant idea of changing them to their improper fraction. So before I do any steps about flipping, the first thing I want to do is write this as its improper fraction. So we remember we multiply and then add. So I would get 5, and again, the reason that I do that is because I'm getting a common denominator. I'm multiplying that 4 times 5. That's the common denominator. That's this first step right here. So I get 20 plus 3/4. So 23/4. That is the mixed number. And the multiplicative inverse would be that guy flipped over. Numerator and denominator switched. Just to point out, the sign, whether it's negative or positive, will stay the same with the multiplicative inverse. It is the additive inverse, I erased it up here, where the signs change. So the additive inverses we're changing whether it's positive or negative. For the multiplicative inverse, we're changing the numerator and the denominator. Sometimes people think you have to put both of those together. Addition and subtraction are inverses of each other, and multiplication and division are inverses of each other. So you think about that positive, negative, that has to do with adding and subtracting, and fractions is really a division. So that multiplicative inverse is going to be dealing with that fraction, with that dividing, with that denominator.